This is a lesson for Chapter 7, Section 5, titled Using the Pythagorean Theorem, day number 1. And so we've got two different types of problems that we're going to experience in this lesson, and the first one is this. We're supposed to tell whether each triangle is right. And so if we look at Pythagorean's theorem, the converse of Pythagorean's theorem says if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. And so again, all we're doing is just taking the value of a, the value of b, and the value opposite the right angle is always the c term. And we're squaring them, and we're seeing if the square of the two legs equals the square of the side opposite the right angle. So we're looking for the longest side. So there's no right angle symbol on these triangles because we're trying to see if they're right or not. We don't know until we check. And so we're going to take this side right here as the longest side, and this is our c term. So we're going to say 9 squared plus 40 squared equals 41 squared. And so we go ahead and do the work there. 9 squared is 81. 40 squared, well, 4 squared is 16, so I'm going to add 2 zeros. And then when we go ahead and square 41, we'll go ahead and do 41 and then squared, and that equals right there, 1681. And so when we go ahead and add these two numbers together, I get 1681. So when the two numbers agree, then we're going to end up saying yes. The side lengths satisfy the converse of the Pythagorean theorem so the triangle is right. And that's going to be our phrase that we'll end up using when we're going to trying to determine whether it's a right triangle or not. And if it was not, then we would say no. The side lengths do not satisfy the converse of the Pythagorean theorem, so it's not right. So the other type that you'll see is one in which it will not have the graph. And so what you have to look for is the longest side. So this is the longest side, and that tells me that this is equal to c. Doesn't matter which one you call a or b. So you just take those two sides, square them, and add them together, and you see if it equals 28 squared. So 21 squared is 441. 20 squared is 400. 28 squared, let's check. So 28 squared is 784. So 784. So we'll add these two numbers together and we get 841. Well, 841 does not equal 784. So this means that the Pythagorean theorem, converse of the Pythagorean theorem, shows that it's not right. And so that's what we have to state. So we'd say the side lengths do not satisfy the converse of the Pythagorean theorem. So the triangle is not right. And that'll be our phrase for if one is not right. So let's move on to the next type of problem that we'll end up seeing, and it's one in which we're going to have to find the distance between 2 points. So we're going to end up coming up with two different methods to do this. One method is to go ahead and plot the points on a coordinate plane. So if I go over one space to the right, up 5, that is this point here, -4, -2. So over 4 spaces to the left, down 2, there's another point. And so what I have is a distance here between the 2 points that I have to find. See, it's hard to find that distance using the coordinate plane because I don't have the vertical lines and horizontal lines lined up alongside this slanted line. One way you could do it is you could cut out a section and then line it up alongside. But the problem would be is if it didn't exactly make one of those units, and so it was a mixed number of some of those units and a fraction of one. And so what we're going to end up doing is we're going to find out the distance horizontally and vertically. And so I've got this horizontal distance, and I'm going to count these spaces. 1, 2, 3, 4, 5. So there's 5 spaces horizontally, and then I count the spaces vertically. So there's 1, 2, 3, 4, 5, 6, 7 spaces vertically. And so from there I have formed a right triangle. So I can go ahead and use Pythagorean's theorem. So 5 squared plus 7 squared equals c squared, the side opposite the right angle right here. And so I can go ahead and the side c is what I'm looking for in this case. So 25 and 49 is what I get when I square those two numbers. And then I add them together, and that makes 14, and this makes 7, so I have 74. And so what I'm going to end up doing is approximating what that is. And so I see that the square root of 74 is between these two perfect squares, 64 and 81. And so I see that 64 is 8, 81 is 9, so I know it's in between those two numbers. So I can find out how far it's in between by making a mixed number. And so if I subtract the two radicands that are perfect squares, that shows me the distance apart they are. And so I see that when I do that subtraction, I got to borrow a little bit, and I see that I am, let's see, this is a 4 here, and so that makes 7, and this makes 1. So 17 units apart these are, and then I subtract the radicand that I want from the lower one, the one that's smaller, it's 10 units. So what that tells me, it's 8 and 10/17 is a good approximation of what the square root of 74 is. Now if I want to know the decimal form, well, I could divide these numbers, but if that's kind of takes a little bit of time, I could just estimate what that is. And so I see that looking at 17, half of 17 is going to be 8.5. And so 10 is bigger than 8.5, so I'm going to guess it's right around 8.6, 8.7. So either one of those is pretty good approximations, though. So 8.7, I'll say, units. We can see how close we are by using the calculator. And so let's check it real quick. So we've got the square root button right here, and I think I have to enter the number first on this calculator. So 74, square root of that's 8.6. So pretty good approximation there. I said 8.7, so I would have been better off with 8.6. But if you look at 10/17, though, if I divide 10 over 17, you can see how that number is really close to 8.6. So doing that division would have got me a pretty good approximation of what that number is. So 8.6 units, 8.7, right in that range. 8.6, a little better estimation, so I'll go ahead and box that one. So looking at this next one here, what I'm going to do is I'm going to end up trying to come up with a formula for this rather than having to make a chart, because if the points were really far apart, that'd be kind of tough. So let's take a look at what we could do. See, what we want to do is we want to find the distance horizontal. And so the way you find a distance is you look at that word difference. And so if I want to find a distance, I can take a difference. And a difference means I'm going to end up subtracting. I'm going to subtract those two numbers. And that's what I'm going to end up doing here. You see, if you do -4 take away 1. And that's what this formula is saying. It says take the difference of the two x values. See, x2 minus x1, that's the difference between this x component and this x component. So in our example, it would be this. Our distance between, fix that line there, our difference between x2 and x1. So x2, we can just call maybe the 1, and then x1 the -4. So I can do 1 minus -4. And then I can square that. You see, 1 minus -4, that makes a positive 5. And I'm going to square that number. And so you see, and that's the same distance I have here when I count the spaces. So if you want to subtract the two numbers, -4 take away 1 makes a -5, but if you did it the other way, it'd make a positive 5. And you're not really concerned with the negative sign. You just want what that difference is. And difference in this case is just 5 spaces. Well, let's take a look at the y components. So from 5 to -2, you see how that's 7 spaces. And so if I did the difference between those two, I would have, and if I did 5 minus -2, add the opposite, that makes 7. And so even if it was -7, when you square it, you'll get a positive. And so you see how the difference between those two gives us the distance. And so from there, we could go ahead and do this work, 25 and 49, and then add those two numbers together, and we end up with the same value, 74. You see how that is the distance between the 2 points. And that's the same thing we end up getting here, which we said was pretty close to 8.6 units. And so using the distance formula can help you or guide you in coming up with that difference or distance between 2 points just as fast as you could if you graphed it. And sometimes faster if the graph is really big and far apart from each other. So those are the types of problems you're going to see on tonight's assignment. Good luck.